Hello everyone. You're welcome back to the channel. In today's lesson, we're going to look at subsidiary conditions and initial value problems. But before that, let's look at what subsidiary conditions are. The definition says that they are a set of conditions on a differential equation that will allow us to determine which solution we are after. So that's basically what the subsidiary condition does. It gives us a way of determining the solution we want. In other words, how to determine a particular solution. So under that, we have initial conditions, and it is a type of subsidiary condition which is given on our unknown function. So let's say my unknown function is y. So it is given on the unknown function and its derivatives. So I can have a initial condition on y prime, on y prime prime, if that's our unknown function, and it is given at the same value of the independent variable. So let's say I have y at 0 is equal to 2. This is a subsidiary condition. Okay. And I have y prime at 0 also being 3. Since this one means that if x is 0, y will be 2. And it also means that if x is 0, y prime will be what? 3. So this condition here is an initial condition. That's how we are able to know that a given condition is initial condition. And the second one is boundary value condition. Boundary condition, sorry. And this one, the only difference between it is that it is given at more than one value of the independent variable. So the first one I had 1, y at 0 equal to 2. So for this, it is given at more than one value of the independent variable. So this one I can say y prime at 2 is equal to 3. It means I'm given two different values of the independent variable. It means when x is 0, y is 2. And when x is another value, that's 2, my y prime will be what? 3. Since the value of the independent variable are given at different values, we say it's a boundary condition. And this will take us to the next thing, which is what we call IVP. So if I have a differential equation plus an initial condition, then it becomes an initial value problem. Okay, that's how we define an IVP, or initial value problem. So the same way, if I have BVP, that's if I have a boundary condition, and I have my differential equation of it, then it becomes a boundary value problem. Okay, so that's how we define these two. And there's one more thing I want to say. Let's say, let me use a different color. Now let's say my differential equation is in my nth order. Okay, if I have an nth order differential equation, my initial value problem or the conditions will be given until my n minus 1th derivative. So what do I mean by that? Let me give an example here. If I have a differential equation like maybe y prime prime plus 2 equal to 0, and I'm to give initial condition on it, I'll have to give from y, maybe y at 0 is equal to 1, and I'll go to y prime at 0 is equal to 2. So it will be, my conditions will be what? N minus 1. I'll give from my y at x naught and y prime at x naught. So similarly, if it were to be maybe y to the 4th order plus 2x equal to 0, this differential equation is of the 4th order. Okay, then my initial conditions will be from y x naught equal to something, y prime x naught equal to something, y prime prime equal to something, and y prime 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 equal to something. So they must be given to the n minus 1th order. I hope this example clarifies things. So that's one thing you must take note of. So next we are going to practice some initial value problems. Okay, let's look at just one. Let me go to the next page. So I have this. We said y equal to c1e minus x plus c2e 3x. They said this is a general solution of a differential equation y prime prime minus 2y prime minus 3y equal to 0. And they said we should determine the particular solution of the initial condition y at 0 equal to 3, y prime of 0 is equal to 4. So since we have the same value of the independent variable, it's an initial condition. So how do we go about this? We are given the general solution as this. So what we are going to do is to do what? Differentiate our our general solution, because we have y at 0 equal to 3 and y prime at 0 equal to 4. To be able to substitute this side into the equation, we have to differentiate our general solution once. So the first step, we are going to have, what are we going to have? We have the first one, we have y is equal to c1e minus x plus c2e 3x. And when we differentiate, we're going to get negative c1e minus x plus 3c2e 3x. And when we substitute the values or the initial conditions into these two equations, we're going to end up with a simultaneous equation. Okay, so substituting y at 0, said y at 0 is what? It's 3. Y at 0 is 3. So I'm going to end up with 3 is equal to what? Negative, or is it? No, it's just positive. So c1, because x is 0. So when x is 0, here goes to what? 0. So any number raised to the power 0 is 1. And here when x is 0 to it goes to 1. So we end up with 3 equal to c1 plus c2. So let me name this as my first equation. And the second one said when y is 0, x, when x is 0, y will be what? 4. So the second one we say 4 is equal to negative c1 plus 3c2. And let's name that equation 2. So let me go to the next page and write them well. So 3 is equal to c1 plus c2, and 4 is equal to negative c1 plus 3c2. So equation 1, equation 2. Now from our basic simultaneous equation, we can add equation 1 to equation 2. And in so doing, we have 7 being equal to what? The c1s will cancel out, so we'll have what? 4c2. And our c2 will be equal to 7 on 4. Okay. So we can now substitute the value of c2 into equation 1 and say that, or anyhow you do it. So it becomes, we know equation 1 to be 3 equal to negative c1 plus c2. No, sorry. It's just c1 over plus c2. So it means c1 will be 3 minus c2. So, and our c2 is 7 on 4. So it means c1 becomes 5 on 4. So let's rewrite our general solution. Our general solution was y equal to c1 e minus x plus c2 e3x. And because of our initial conditions, we've been able to find the value of c1 and c2. So we will have y to be equal to what? 5 on 4 e minus x plus 7 on 4 e3x. Okay, and this right here is what we call our particular solution. So I hope you enjoyed this lesson. We'll look at another example in our next lesson. Goodbye.